And welcome everybody. It is just after 12 o'clock. My name is Benji Cohen with Minnesota DNR Fish and Wildlife Division, and you are joining us for the 159th episode of the Minnesota Outdoor Skills and Stewardship series of webinars. We had a great topic today talking about climate change or climate landscape changes that affect our cold water fisheries. So with that, I'll turn it over to Derek. Derek Bahr is going to join us. He's our fisheries research scientist, and he's going to share a little bit about some of the research that goes into fisheries and cold water index. So take it away, Derek.
Yeah, thanks, Benji. So I'll kind of cover, like Benji said, some of the research and then some of the work that we've been doing to protect our cold water fisheries, and then Heather will kind of pick it up with some of the boots on the ground protection work. So before I dive in, I just wanted to highlight a few relevant MOS recordings that folks might find interesting that fit in with today's talk. So the first being one that talks about shoreline habitat, so that'll fit in and dovetail nicely with some of the work that Heather's talking about kind of landscape protection. There's also a number of talks that are more geared towards lake trout and Cisco and lake whitefish biology and angling and sport fish or sport netting opportunities for those species. And then even how things like Cisco fit in as an important diet item for muskies. So be sure to check those previous recordings out if you're interested. So with that, Minnesota is home to a handful of lake-dwelling cold water fishes. So the ones I'm going to be talking about during today's talk include lake trout, lake whitefish, and Cisco. They're all part of the family of Salmonidae. And for lake trout, they're generally found in the northern part of the state. Typically, you're thinking Canadian Shield type of waters in the Rainy and Lake Superior basins, whereas whitefish and Cisco are a little bit more widely distributed throughout the state and can be found in the Mississippi Basin and the Red River Basin as well. I did want to point out that there are also several other lake-dwelling cold water fishes, including native brook trout and non-native brown trout and rainbow trout in some of our lakes, as well as species like burbot and deepwater sculpin that also need cold water habitat to persist. So these cold water fishes are important for a number of reasons. The first being, if you're an angler, you might be targeting these individual species. So either by angling or if you're interested in Cisco and lake whitefish, you could catch them by angling, but you can also use a technique of sport netting to capture them in the fall or by commercial netting. And if anyone's tried these species, they make great table fare. You can grill them, you can smoke them. They're great prepared a number of different ways. They're also a really important forage item for game species like muskies, northern pike, walleye, and lake trout. There's been some studies that have indicated increased growth and trophy size potential for these predator species. So kind of a hint that if you're an angler that's interested in trophy opportunities, you might want to sort of narrow down your search of lakes, those lakes that support species like Cisco. And all three are really good indicator species. So that basically means that they're sensitive to and they respond predictively to various stressors that are occurring on the landscape. Because of their importance and because of the recognition that they're sensitive to different stressors, DNR has sought to monitor these populations and observe trends through time. So sort of the gold standard that we use for Cisco monitoring is vertical gill nets and hydroacoustics. So the pictures here sort of illustrate both of those two gear types. And basically with vertical gill nets, they're a panel of mesh that's set from the surface of the water down to the bottom in the deepest part of the lake. So you can get depth information for where those species are utilizing depth in the water column, and then get great estimates of density and biomass in an individual lake. But this approach is sort of labor and time and cost intensive. So generally we default to our standard gill nets, which are set in a much broader number of lakes. And those are generally targeting our warmer water species, our top predators like pike and walleyes. But we do incidentally catch Cisco in these nets as well. And then for species like lake trout and lake whitefish, they're more bottom oriented. And so if these nets are set in deep habitats, they can also be very effective for sampling those species as well. So if we look at something like our standard gillnet catches over time, this plot is just illustrating, we've observed a decline in our mean Cisco catch per standard gillnet lift observed in our inland lakes since the netting protocol was standardized in 1993. And because of that decline and some other information that we have, we can start to understand some of the threats to our cold water fishes. So this is just kind of a bulleted list of some of those bigger drivers or bigger threats. And they include things like cultural eutrophication. It's a big word, but basically it means excess nutrients in our waterways. Climate change, which can impact things like our lake temperatures. Aquatic invasive species, like the picture here shows a rainbow smelt. This particular species can compete directly with our cold water fishes for resources. They can also prey on eggs and larval Cisco and lake whitefish. And then if they're consumed by species like lake trout, they can actually reduce their reproductive success. And then lastly, pointing out just that, historically there's been some overharvest that's also happened that's impacted these species. So to take a little bit deeper of a dive on that cultural eutrophication side of things, like I mentioned, this is functionally excess nutrients that are entering our lakes. And in Minnesota, sort of the limiting nutrient is phosphorus. So as kind of a side note or a fun fact, if you were to dump 1 pound of phosphorus into a lake, that would be capable of producing 500 pounds of algae. So that's why we really focus on or try to promote shoreline buffers and reducing lawn fertilizers, especially on properties that are associated with lakes, and a number of other BMPs that can reduce those inputs. So phosphorus and other nutrients can enter our lakes through a couple different means. So point sources, those are the ones that we can narrow down exactly where that input is coming from. So that would include things like wastewater treatment plants or industrial facilities. We also have non-point sources that it's a little bit harder to put your finger on where those inputs are coming from, but generally it's associated with things like runoff from lawns or farm fields. It can also include things like faulty septic systems on properties adjacent to a lake. And so the concern here is that increases in lake productivity, like algae blooms, when those algae grow, they eventually die and then they settle to the bottom of the lake. And in order for those to be broken down by bacteria, the bacteria actually need to consume oxygen. And so this results in a loss of oxygenated habitat in those deeper, colder parts of the lake. Related to climate change, we've seen an increase in air temperature through time, which is also correlated with what we've seen as an increase in lake surface temperatures. This also results in things like an extended stratification period for our lakes, or the amount of time that our lakes are thermally mixed in the summer, or thermally separated in the summer, excuse me. And then also seeing things like reduced dissolved oxygen levels in lakes as a result of things like expanded growing seasons, increased growth rates, and increased respiration demands in these systems. So before I dive into some of the specific work I've been doing, I just wanted to cover a little bit on the limnology side of things. So one really important principle as we talk about our lakes is that water is most dense at 4 degrees Celsius or 39 degrees Fahrenheit. So if we have a hypothetical lake, this is kind of a profile from the surface down to the bottom. In the spring, all of the water is the same temperature at close to that 4 degrees Celsius or 39 degrees Fahrenheit range. And so there's no density gradient. So the water is all the same in terms of how it can just mix throughout the water column if you have a wind event or something like that. Whereas in the summer, we end up with 3 distinct layers of water. So the surface layer, the one that's the warmest and that can mix with the air, is the epilimnion. So as the surface warms, there becomes this gradient in densities from the warmer, lighter water at the surface, and then you transition to the metalimnion, which, if you're an angler, you might refer to it as the thermocline. That's the period or the depth range where the sharpest gradient in temperature change occurs. And then the hypolimnion is the deepest, coldest habitat you'll notice here. Even in the summer, those temperatures can be anywhere from upper 30s to low 40 degrees Fahrenheit. And these waters are separated because of that density gradient, and so they're limited really in the amount of oxygen that they contain to what was present at the time of turnover. Then as we transition into fall, those surface temperatures begin to cool, and eventually once they hit an equivalent to the temperature at the bottom of the lake, that density gradient no longer exists and that water can mix freely throughout the water column. And then the other one is that, as we transition into winter, those surface temperatures begin to cool even more. So because water is most dense at 4, if it's less than 4, it's actually functionally lighter. And so that's why ice floats. So in this case, you get ice forming, and then the coldest water below that, and progressively as you get deeper, it warms up to that 4 degrees Celsius temperature. So I do want to also point out that stratification, this term that I've been throwing around, is also influenced by things like lake depth, size, shape, and fetch. And so if you have a lake that's generally deeper and smaller relative to the amount of wind that it receives, the more likely it's going to be a stratified lake in the summer. So now that we've got some of those basics, I wanted to provide kind of an example or walk through an example of a lake and what happens throughout the course of the different seasons. And so this is just a hypothetical lake, from the surface at the top down to 40 feet at the bottom. And as we transition from spring to summer to fall, from that period where it's mixed to stratified and then mixes again. So if we look at that sort of May through October, in May, the water is cool enough and has enough oxygen, it's all well mixed. But then as summer sets in, you get warming of those surface temperatures and a decrease in dissolved oxygen in those deeper, colder habitats, which functionally results in a summer squeeze, or a period of maximum oxythermal stress, as we also like to call it, before the lake again turns over and provides that habitat that the species can utilize throughout the water column. So we can hone in on this period of what we call the summer squeeze and measure our oxythermal habitat during that time. And so here's an example of a temperature profile where we're looking at the vertical y-axis here. The shallowest surface depth is at the top and the deepest location is at the bottom. And as we move across on the horizontal or y-axis, you can see that from those surface water temperatures, they range anywhere from 25 down to about 23 degrees Celsius. And then you hit the thermocline where there's that steepest transition in temperatures. And then once you get to about 10 meters in this profile, that's the hypolimnion, where that water is anywhere from about 5 to 8 degrees Celsius. Then we can also overlay our dissolved oxygen profile, which follows a very similar pattern to what our temperature profile does, where you have the most oxygenated water in that mixed epilimnion, and then it gradually decreases over time, and in this case becomes anoxic, or there's no oxygen in these bottom two depths. But this would be an example of a lake that has relatively low nutrient inputs into it, so it does have some good habitat. So if we look at maybe what the maximum temperature is for these species and the minimum dissolved oxygen requirement for these species, and sort of fit that into a hypothetical lake, there's about 7 or 8 meters of good habitat, good cold oxygenated habitat for these species. One really important measure that we use to sort of characterize oxythermal habitat, we call it TDO3. It's a single variable that represents temperature at a benchmark oxygen concentration of 3 milligrams per liter. So just kind of want to walk through how that's calculated. So we can look at where the dissolved oxygen level is 3 milligrams per liter, and then see what depth that's associated with, and then essentially draw a line over to the temperature at that depth. And we can see that the temperature associated with that depth, or the TDO3, is 6.1 degrees Celsius, which is cold. So that's implying that there's good cold oxygenated habitat in that lake for species like Cisco, whitefish, and lake trout. But if we look at a system that has more productivity, so more nutrients, you can see that in this profile, the temperature pattern looks very similar, but that the dissolved oxygen is functionally depleted even within the thermocline. And so in this case, if we calculate TDO3, it's occurring at a depth that's closer to 7 meters and corresponds with a temperature of 22.1 degrees, which is too warm for a species like Cisco to persist. So now that I've provided some sort of basic overview of what we're interested in and looking at, I'm going to just talk a little bit about some of the cold water standards rulemaking that we've been working on within the DNR and with the Minnesota Pollution Control Agency. And so we're interested in looking at nutrient and oxythermal benchmarks that lakes should attain to support these species in the future. And then, like I mentioned before, Heather's going to be talking a little bit more on the forest protection and land acquisition side of things. And so for that, we've got several tools that have been employed where we can prioritize lakes based on, for this first example, Cisco refuge lakes, the likelihood that those lakes will support Cisco given future climate projections. And then for the lakes of biological significance, that list incorporates information about whether there are naturally reproducing lake trout and lake whitefish populations. And so you can see how that kind of feeds into that aspect. And you'll probably notice that through most of the talk today, we're largely focusing on the eutrophication stressor, because that's one that we can adjust the dials, so to speak, kind of more on a local watershed by watershed level. So we can have more of an influence on how we manage nutrients that are entering our lakes and protect that cold habitat and maintain those oxygen demands or those needs for those species. And so first thing I wanted to touch on here then is, what are our current water quality standards regarding or related to nutrients and how might they protect our cold water lakes? And so this is a table that shows total phosphorus, chlorophyll A, and Secchi transparency, or basically how clear the lake is. And so you'll see that we do have several standards on the books that are geared to protecting lakes that support lake trout and stream trout fisheries. But there's a number of lakes outside of those that include Lake Whitefish or Lake Cisco that wouldn't be protected by those criteria. And those would fall in our northern and central lakes categories, which those standards were really more geared towards our warm water fisheries and kind of recreational use opportunities. And so when you start to see nutrient levels that are exceeding those amounts, you've already functionally depleted most of the dissolved oxygen in those cold waters that those species need to persist. So we recognize there's sort of a gap here in our protections. And so because of this, we sought to build out these cold water standards. And functionally, the first step was to inventory and designate our cold water lakes, which involved looking through a bunch of historical records and having lots of conversations with area fisheries managers throughout the state to get a good handle on what the status of our cold water lakes were. And then the next step was to develop and evaluate potential thresholds, kind of getting at that oxythermal metric, TDO3, and then eutrophication using kind of the conventional set of water quality standards that we already have sort of a framework for in Minnesota. And so for the first part, when we inventoried our lakes, we found out that we have about 855 lakes where we've documented cold water species through various survey efforts through time. And of those, we were really interested in the stratified lakes because those are the ones that the nutrients can have a big effect on how much oxygen is found in those deeper habitats. And so in this case, there's 116 lake trout lakes in purple there. Most of those are found in the Canadian Shield, a lot of them in the Boundary Waters Canoe Area Wilderness. And then those lakes, I should note, could also include Lake Whitefish or Cisco. And then as we kind of move down to the next notch, we have 68 stratified Lake Whitefish lakes that could also include Cisco, and then 396 stratified Cisco lakes that we were interested in building out some standards for. So then the next step was to sort of look at some of the existing research that had been done and see how our data kind of fit with that. And so this plot that's on the left is looking at sort of the distribution of each of those three species in lakes relative to the measured TDO3 associated with those lakes during the summer. And so as we compare this with previous research, it lined up very well in that lake trout need the coldest, most oxygenated habitat to persist, followed by lake whitefish and then by Cisco. And then the plot on the right is a little bit more interesting in that it's looking at the probability of occurrence of each of the three species. So a 0 meaning that it's unlikely to occur in a lake, and a 1 indicating that it's very likely to occur in a lake. And then as we move through x-axis here, as we increase the temperature or the TDO3, so as the habitat becomes less available, we actually see a notable decline in all three species across that gradient. We're also interested in understanding how our measures of relative abundance from our standard gillnet surveys sort of fit with this data. And so we used Cisco kind of as our test subject because we had the most data available for this species. And looking at both our TDO3 measure and chlorophyll A as a measure of productivity in the lake. We observed declines in our average catch per net of Cisco as you increased TDO3 or decreased kind of the available oxythermal habitat, and then as you increased chlorophyll A or productivity in a lake. So that was really important. For the next step was actually setting the thresholds. And so we used an approach that has been widely used to set water quality standards in other states. And so we used this 95% extirpation value, or XC95, based on an abundance weighted cumulative distribution for each of these three species. So if we focus in on Cisco in this example, functionally 95% of the Cisco that we've documented in any of our DNR surveys were sampled in waters that were cooler than 21.5 degrees Celsius. So picture that, if we had 1,000 Cisco that we had sampled over time, 95% of those would be to the left of this vertical red line. So that was what we used to set our TDO3 potential thresholds for Cisco, lake whitefish, and lake trout. So you can see those three proposed standards there. So for Cisco, that's 21.5 degrees Celsius. For lake whitefish, it's 17.2. And for lake trout, it's 8.8. And then we were interested in seeing how those standards sort of compared with what I showed on the previous slide, which was that probability of occurrence. And so the vertical red dashed line are the proposed standards for each of the three species. So you start to see a notable decrease in their probability of occurrence at those thresholds. I do want to point out that there's a number of lakes that have much colder, much better oxygenated habitat available than what our proposed standards are set at, but that's sort of viewed as a minimal standard needed for these species to persist. And so the goal would be to protect and maintain that great oxygenated habitat in these lakes that kind of fall, to the far left of each of these graphs as well. So we took a similar approach as we did for TDO3 for setting our nutrient thresholds. So we focused in on that chlorophyll A measure to set that threshold, and then we modeled the total phosphorus and Secchi depth thresholds associated with that chlorophyll A value, and applied that framework across the three different cold water lake types. So you can see what our proposed or preliminary thresholds are here on this table. And then what we can do is begin to look at how our thresholds compare to our current water quality standards in the state. And like I mentioned, we don't currently have an oxythermal standard or a TDO3 standard on the books. So it's really important that we develop that, which it also allows us to sort of disentangle the effects of climate and eutrophication on our cold water lakes, and sort of pinpoint some action steps moving forward if a lake were to, say, hypothetically become impaired or exceed our proposed standards down the road. And so if we look at lake trout lakes, and we look at our current standard of 3 micrograms per liter of chlorophyll A, and we compare that to our preliminary proposed threshold for chlorophyll A, they're the same. And so, functionally our current standards are supportive or protective enough for lake trout lakes. But then as we move to lake whitefish lakes, our preliminary threshold is much lower than what the current standards are, meaning that, in these cases, productivity would be allowed to increase beyond a point that would be sustainable for these species. And so our proposed thresholds would be more protective in that case. And then for Cisco lakes, it's sort of mixed. And so our proposed standard of 12 is below the north standard of 9, but above the, or excuse me, I have that backwards, above the 9, but below the 14. And so in one case, that doesn't check out. And so this leaves us with 68 lake whitefish lakes, which are not also lake trout lakes that would benefit from that lake trout protection, that are in need of some additional protection moving forward, and 114 central region Cisco lakes, which are not also lake trout or lake whitefish lakes that would benefit from this additional protection. So kind of to wrap that up or distill it into one slide here, our preliminary thresholds for TDO3 and chlorophyll A with our modeled total phosphorus and Secchi thresholds indicate that many lakes with Cisco or lake whitefish currently do not have protective enough standards for these species. And then the inclusion of a TDO3 standard in particular will improve the effectiveness of our water quality standards for these sensitive fish species. Like I said, we can sort of begin to tease apart some of the different effects of different stressors when we have both complementary standards in place. So if you're interested in learning more, we have a link here, which I believe Benji will drop in the chat. And so certainly feel free to check that link out. It's hosted by the MPCA, and it includes a timeline for where we're at in the rulemaking process. It also includes technical support documentation, which provides information about our lake use designations, so assigning the different cold water classes to those lakes, Cisco, lake whitefish, and lake trout lakes, as well as development of our standards, and then implementation procedures if this moves forward in the future for how we would monitor and assess these lakes. So with that, I just have one more slide here that talks about some of our monitoring efforts with anticipation that these rules would be adopted at some point in time. And if at the very least, it provides us some great baseline information about some of the lakes that we haven't really sampled very routinely for oxythermal habitat in the past. So we began more intensive monitoring in 2022 to assess our cold water lakes. And this picture shows Heather. She was out in the Boundary Waters Community Area Wilderness last year, taking an oxygen profile on one of our lakes that we really just have some limited data on. And so this is set up to follow our MPCA watershed assessment cycle, which is geared towards sampling lakes on a 10-year rotation across all of our watersheds. And it focuses on the deepest location in a lake during that period of maximum oxythermal stress, or that summer squeeze period, which corresponds with July 26th through August 24th. And then, the minimum data requirement would be that these would be collected over 3 years in kind of a 10-year period to sort of get an average perspective on what the habitat looks like in these systems. So I wanted to just thank a number of people that were involved in this work. I mentioned there was a lot of work that went on to inventory our lakes and dig through historical records. And then Will Bouchard works with MPCA, and he's sort of my counterpart that we've been working really closely together on this project for. So with that, I'm going to turn it over to Heather. Stop sharing here and she can pull up her screen.
Great, Derek. Thanks for all that great information. I did have one question from Eric that popped up in the Q&A. What were the numbers for amount of phosphorus to pounds of algae again? I believe you said it was 100 to 500.
Yeah, it's pretty incredible. Yeah, essentially, if you were to add a pound of phosphorus, that would be equivalent of growing 500 pounds of algae in a lake. So, yeah, pretty impressive. That's why we really stress the importance of good riparian buffers with natural vegetation and septic system inspections and all of those things, because small things can have a large impact on our water bodies.
Great, thank you for that. And we'll turn it over to you, Heather, and you can talk a little bit about some of the things that are happening with our forest and cold water fisheries. And just to remind everybody, I did put a bunch of links in the chat if you want to click on any of those from Derek's presentation, and I'll share some more with Heather's presentation here when she gets going.
Great. Can you see my presentation now?
Do you want to put it in slideshow mode?
Oh, I thought I was. It shows it as slideshow on my end. What's it look like now?
Still the same. I'm still seeing
That's
the
weird.
next slides, I guess, on the left-hand side there, but if it works with you, we can just go with it too, because we can see it. So
Otherwise, Heather, if you want, I can resume sharing again and I can just navigate through them.
Yeah, it's
the wonders of technology.
no. How does it look now? Is it the same?
No, we're seeing your screen now. So
Okay. Yeah, Derek, maybe just share and I'll just have you advance just so it's a better. I'll stop sharing here. Sorry about that. So I'll just begin. My name's Heather Baird. I'm the Fisheries Forestry Landscape Coordinator, and I work out of the Brainerd DNR office. Today I'm going to talk a little bit, I'm going to follow up on Derek's great talk on the research and some new standards going forward for cold water fish. And I'm going to talk a little bit about efforts to protect their habitat through landscape level forest protection, through conservation easements and acquisition. So many people think of fish habitats as one of these pictures here: aquatic plants with this northern pike in it, woody logs, down trees along lake shores, and nearshore habitats such as docks and structures along shore that we create. But the Minnesota DNR has spent many years enhancing and replacing shoreline habitat, that nearshore littoral habitat that we saw in the previous pictures. With private landowners, we work to plant native plants on shorelines, to create upland buffers, to create nutrients from running in and slowing water and runoff coming into the lakes. And we also planted native plants and aquatic plants in the lake to create some nearshore fish habitat. And this picture of the shoreline, this is the same picture you saw of us planting it in 2000, 12 years later. So this is Sugar Lake or Sissebaquet Lake up in Itasca County. This landowner really wanted to convert their mowed lawn to some nearshore habitat and create some better habitat for fish, and also reduce their nutrient footprint into this lake. So you can see, you know, after 12 years, these plants have really restored themselves. The trees have grown up, and we've made some great efforts protecting this shoreline. But we didn't really make an overall large impact on a lot of lakes throughout Minnesota. And the research was showing that we really needed to expand our efforts in order to protect fish habitat. And we were missing other habitats. We were missing these cold, deep lakes in forested watersheds that we don't often think about as fish habitat. As Derek was mentioned, he just had a great presentation about the habitat needs for Cisco, whitefish, and lake trout. And we weren't really keying into their needs and what was needed to protect those habitats. So based on some research by Tim Cross and Pete Jacobson, we saw the need to move to a larger landscape effort to protect and enhance lakes for these fish species. So we moved to a watershed or a catchment scale to work on this effort. So again, in expanding this work to the watershed level, you can see here in this map of Pelican Lake, this is Pelican and Crow Wing County. This is the small watershed or catchment level of this lake in the yellow outline. We moved to a larger landscape with more private land, more nutrient loading, and less DNR control. The DNR doesn't have much regulatory authority on private lands or within local government units around and within this watershed of Pelican Lake. And so really we lean on efforts like zoning efforts and the local government units to really put regulations in to help nutrient loading and impacts to the lakes and the watersheds. So this landscape level work also meant a lot more to restore and protect, as we have a lot of forests that have changed or been converted. As you can see in this graph, the population changes in Minnesota are really big, and where people live in the state of Minnesota is changing over time. And so in order to provide homes and places for people to live and lake cabins, we've really lost a lot of forested lands, especially around our lakes in central and northern Minnesota, to provide for this. This slide shows a loss of forested land since European settlement in the upper Midwest. So the graph on the left shows a pre-settlement forest through central Minnesota down through Wisconsin and the UP of Michigan. The graph on the right is modern era forest. So you can really see changes here. If you just key in on, I know the legend is small, but if you key in on those last four bright colors, the teal, the orange, the yellow, and the lighter teal colored, those are changes of forest to non-forest today. So really, you can see a really significant impact and changes to the loss of forests on the landscape through central Minnesota, down through much of Wisconsin, the central lower part of Wisconsin, and then the lowest part of the UP in Michigan. So really, all these changes in non-forest have impacts and significant impacts on our lakes and our rivers and our cold water fish species that live in those deep, cold lakes. So it's all about protecting the sponge. So the forests are sponges, filtering the nutrients off the land. These large, with climate change, one of the things we didn't talk about in Derek's talk was these changes in rainfall events. So we now have increases in rain events that cause 4, 5, 6 inches of rain that comes over a short amount of time. And really that floods these nutrients into these lakes in areas where we don't have good forest cover. We don't have that sponge to filter out those nutrients or slow down that rain to carry those nutrients in. So really it's all about protecting the forested landscape to keep the water quality in these lakes for the cold water fish. So Minnesota DNR created a fish habitat plan in 2014 based on the research of Tim Cross and Pete Jacobson that I had mentioned earlier, working at a watershed scale. And so if you look here on the y-axis, we have the percent of watershed protected. And on the x-axis, we have watershed disturbance. So in those lower areas where you have less watershed disturbance and higher watershed protection, we've got a lot of lakes. We've got a bunch of lakes in that dark green, that vigilance area, where we really don't need to do much protection. And there's not much protection to do because a lot of these are in federally protected areas like the Boundary Waters Canoe Area, the Superior National Forest, the Chippewa National Forest. And then we move down to that light green where protection is needed and still needed. And we need to look out for those lakes where there's areas of watershed that could be converted to agriculture or grazing, or split up into like 1 acre homesteads or cabins for people. So more development on the landscape, more roads. And then when we look at the yellow area of this, where watershed disturbance and watershed protection is kind of lower in there, we still have some efforts in some small watersheds where we can make a difference and keep those watersheds forested to keep some good habitat on the landscape for fish. So really what we're looking at here is central Minnesota. So we're looking at the need and the urgency here right in the central part of the state. This was about 12 years ago where we were looking at forests to pines being converted to potato fields over in Hubbard County and coming from the west. So a lot of forest conversion for agriculture and a lot of forest conversion for other crops as well, too. So really the need is in the central part of the state where Derek showed, the upper Mississippi is still good habitat for Cisco and whitefish, where they stretch down into this central area. And so this is where the direct threats and the need for forest protection is the greatest. So we're looking to move towards a strategic framework and how we do work. So really the yellow boxes in this graph and the green are where we want to work. We're looking at that low shoreline disturbance on the landscape and that low watershed disturbance. So really concentrating our efforts where we can protect forests, maybe do some shoreline restoration, protect good shorelines, because there's still a lot of really good shorelines out there, and protect the cold, clean water for fish habitat. So protecting 75% of the watershed of a lake keeps good water quality for fish. That's the main premise behind a lot of the work. With the research and knowledge of this cold water fish and the habitat needs, there's a lot of people working on landscape level protection. We've got a lot of the Trust for Public Land and Minnesota Land Trust, Northern Waters Land Trust, the Nature Conservancy, a lot of nonprofit organizations, along with DNR, are really working on landscape level protection efforts for not only Cisco lakes, but Derek mentioned lakes of high biological significance. So using some outdoor heritage funds and really working on conservation easements, acquisition, and other BMPs too, restoring forested areas on the landscape to protect this water quality on the land. There's continued research as well, too. There's ongoing research and a continued need for additional research to refine the scope of the landscape protection efforts. For instance, we know warming temperatures impact cold water fish, but what about increasing rain events that I'd mentioned? These increases of higher pulses of rain that come during the summer that bring increased nutrients to the lake. What about BMPs that we can implement after we've protected watershed levels to 75%? And can we have a grazing BMPs? Can we fence out cattle? Can we have forest management plans that really help to protect water quality in these cold water lake watersheds? So this is Cisco, Coregonus artidi. This is another picture of the Cisco that Derek presented. They're also called tulabi if you are an angler, or you know them as tulabi instead of Cisco, and they're odibinis if you are a Ojibwe. And these are a culturally important resource as well as a resource for anglers and for our top trophy fish. As Derek mentioned, they're the base of the food web for a lot of our top predators like walleye, muskie, northern pike. And these feed on Cisco. And as Derek mentioned, there's a lot of research supporting the fact that a lot of our top predators grow larger and become bigger in these lakes that have Cisco as the base of the food web. So another important reason to protect Cisco on the landscape. So again, why protect Cisco? So why is all this effort to protect Cisco? We protect Cisco because they need cold, clean, well-oxygenated waters to survive. When we protect Cisco, we protect the habitat for many other species of fish, prey for top predators, as I just mentioned, muskie, walleye, and northern pike. And when we protect these lakes, we protect the best habitats in the state of Minnesota. So some of our best lakes with the best water clarity and the best places to go recreate in the summer are also Cisco and coldwater lake habitat. So again, this is another graph similar to what Derek showed of the warming temperatures. This happens to be the average winter daily minimum temperature. And we can see really in the past 30 years, we've really been warming. We've had some exceptional warm winters. You can see those red dots, which are the 10 warmest winters in history. And this doesn't show this winter of 2024. It ends in 2021. So I'm sure the red dot, when we expand this graph, will be much higher than the current highest red dot on this graph. But again, we are warming, and we're warming at an alarming rate. And so as Derek mentioned, we can do things to protect and reduce climate change, but where we really need to put our efforts is protecting the nutrient runoff in these lakes and keeping that at a low level so that we're not decreasing oxygen in the lakes, especially during the warmest temperatures, since the open water season, ice off season is really expanding in Minnesota. And so we're definitely seeing a threat to Cisco with these warmer temperatures. So Cisco land use stressors. So here you can see nutrients in the lake. So this is a change in the total phosphorus over the last 85 years. So the black on this map is the forested areas of the state. So the forested region, the gray is a transition, and then the white or more lighter colored grays are a transition to prairie agricultural land and grazing. So you can see that the fewest changes, the dark green circles there in phosphorus, so the lowest changes in phosphorus input are really in the forested areas of the state. There's little to no increase in the phosphorus happening where we've got a good forest cover and forest lands in these watersheds. As we move more towards central Minnesota, again, Cisco and whitefish range, we see increasing with the yellow and the orange. So increasing in phosphorus nutrients into these lakes and watershed. So again, this really hones in on the need to protect these forests in central Minnesota and these forested landscapes around these cold water lakes. So we also have increasing nutrients in the lakes. And this slide depicts the direct connection of phosphorus to cold water fish habitat. So this is a reiteration of what Derek showed in his graph where we were seeing the Cisco squeeze in the summertime. So this is our direct connection. You have phosphorus added to the lakes with maybe increased rainfall events, or someone had added some nutrients to their lawn. And so we add this phosphorus to the lakes, and that increases the plant growth and the algae growth in the lake. When these plants and algae die and they start to decay, they fall to the bottom of the lake, and they really use the bacteria, and decomposition uses up the oxygen that is needed for fish and other aquatic organisms in the lake. And so that can deplete the oxygen levels to lethal levels for these cold water fish, and making these species of fish move up in the water column, where in the summertime may make them reach lethal summer temperatures. So really that summer squeeze can happen when we add too much nutrients. And so keeping the nutrients out of lake by keeping forested watersheds is really the key. So we've partnered with Forestry and Forest for the Future, which is a federal program, and many other land trusts in the state to put conservation easements on private forest lands to keep them forested, to keep them converted from housing developments, keep them converted from agriculture, while still doing good forest management practices on the land. So other land trusts help with these conservation easements, like Trust for Public Land, Minnesota Land Trust, Northern Waters Land Trust. And the conservation easements really pay the landowners to give up the development rights while they're still allowed to manage forested habitat and forest health on their property. So again, this is the Pelican watershed that I showed earlier. And the gray area or translucent area on the map is really all private land. So you can see how much private land is in this watershed. The green is some forest, DNR forest lands, and the purple are some fishery aquatic management areas. And I'd like to concentrate on the red outline in the southeast corner of Pelican Lake here, which is the Minnesota Elks Camp, where we worked with the board of that camp to put a conservation easement on to protect the forest from development. So here you see the conservation easement outlined in red. So there were 193 acres protected from conversion to other uses by putting a conservation easement on this property. It also protected Little Marquee Lake, the shoreline of Marquee Lake, and the shoreline of Stevens Lake. The camp facilities abut right up to Pelican Lake, and they chose to leave that out because there was already some houses and camp structures there, and they may need to expand that in the future. But we've really done a good job of protecting this 193 acres of forest land. And the camp uses forest management. They do some timber harvest every 10 to 15 years when needed to create some revenue for the camp. So that really helps bring in some funds and allows them to have additional income come into the camp. So really this camp, it was, once thought possibly could be another golf course on Pelican Lake, could have been sold off, could have been housing development, but now is permanently protected to protect water quality and a lot, not just Pelican Lake, but a lot of the lakes in that area. So this is 10 Mile Lake Watershed. This is about 77%, probably 78% protection now. We've actually just, the Minnesota Land Trust acquired another easement on this lake that I don't show on this map. But we worked on the McGill property, which is 120 acres to the west of 10 Mile Lake. And they were a forested property owner, really enjoyed nature, did a lot of bird watching, had some forest trails. Also did some timber harvest to gain some revenue, but really wanted to keep this forested land forested. And this property abuts up to some state forest land, some DNR state forest land, and that light green. And so it keeps a nice corridor for habitat. 10 Mile Lake was very close to 75% protected because the northern part of the watershed, all that dark green in the watershed line is the Chippewa National Forest, so already protected lands. So again, 10 Mile Lake is a lake that's got more protection. Is there more to do in this watershed? Certainly, but it will protect the water quality and deep cold water for Cisco and lake whitefish in this lake for future generations. So this is Cabacona Lake. This is over in Hubbard County. This is another Cisco lake. We chose a lot of the lakes that were close to the 75% protection when we started this work to key in on easements and really trying to prioritize some watersheds where we thought we could meet that mark. And the red squares here are conservation easements that we worked on and we've put on the lake for Cabacona Lake in the watershed. The green, the light green, again, is state forest land, and that's the Paul Bunyan State Forest to the south. So a lot of this watershed you can see is already protected in state forest land. And then the yellow is county administered forest land. And so if we hone in to the next slide on this property, this is the Anderson property. This is 34 acres just off Cabacona Lake. Protected this land with a conservation easement. It's adjacent to the Paul Bunyan State Forest and not far from the Lester Lake SNA, Scientific and Natural Area. And this property was left to the family by the grandfather, and really they wanted to see it protected as forested land. They didn't want to see future generations selling it off for second-tier development. And certainly we're seeing that on a lot of our best lakes. These great water quality lakes, if you can't live on the lake, you'll live near the lake. And so they will develop the other side of the lake and try to get some access to the lake. So really, this is a great protection from second-tier development into the future. This map, I know this map is very busy. This map was created by the the Northern Waters Land Trust. And it really depicts, like here they show the Paul Bunyan State Forest in brown to the south. This is the Cabacona watershed again. But this was on their website. I think it's still a link on their website if you want to go there and check it out. But they really celebrated this summer. They've reached the 75% watershed protection in the Cabacona watershed. And so this is a milestone. This is a lot of work by a lot of partners, DNR, Minnesota Land Trust, Trust for Public Land, TNC, Forestry. Just a lot of partners went in to protect this land and the lands around the Capicona watershed. So they really celebrated this, and kudos to them. So now they're really looking towards other BMPs they can do in this watershed to continue to increase the water, or increase and protect the water quality coming into Capicona. So again, they're looking at maybe some grazing plans for some grazers in the watershed and just outside the watershed, and some other potential management plans for private forest lands owners to protect the forest and keep them well managed in this watershed. So really, you know, there's a lot of celebration that goes on when we reach the 75%. And I think not only just the lake owners around the lake, but also people within that county and that live near these lakes celebrate. So what can you do? What are the next steps? So volunteers can collect temperature and oxygen profiles in lakes and rivers near you. You can help to contribute to the missing data and the data needs for water quality around the state. You can get involved in watershed restoration and protection strategies and one watershed, one plan efforts in your local watershed. So really, these come from the local government units. So if you live in an area with a watershed district or soil and water conservation district, go to their website or give them a call. And they're certainly looking for private landowners and people interested to participate in these efforts. And they'd be glad to have you on board and glad to give you the background information for that. You can follow BMPs or best management practices to minimize nutrients into lakes. If you live right on a lake, certainly, you know, consider planting a native buffer. Check your septic systems if you have a septic system. Reduce fertilizer use, and that goes for everybody because we all live in a watershed. And then if you own over 20 acres of forested land, you could consider a conservation easement. And I think Benji's going to put in the chat, I copied some websites for Minnesota Land Trust, Trust for Public Land, Northern Waters Land Trust, and any one of those could help you with private conservation easement. And then make climate-friendly choices as you go forward. And thank you. That's all I have. I don't know if we have time for questions.
We got just a couple minutes left, so I don't know if we'll get through all of them. We don't have too many questions here, so thank you to both of you for presenting your research that you've done on these cold water fisheries and kind of the new stuff that's coming out, and Heather for sharing kind of the next steps and what we can do to help protect our waters going forward. So Dominic had a question in there about who to contact if ponds overfished, or they have questions about an area pond. So I put an area fisheries office map in there. That's probably your best bet to reach out to your area fisheries office for that. Matt had a question: is it important to plant climate resilient tree species in addition to coniferous trees when taking on habitat buffer projects?
Yes, it is. And there's a great group called NIAX. I forget what it's like, North American Climate Atlas, out of Michigan. And I can certainly send Benji the link to that. They're out of Northern Michigan. And they've actually created a tree atlas on tree species that they believe are going to be the best for our shifting climate, for our increasing rain and our warming, the warming trends. And so, yeah, you can actually click on an area. They've got an interactive tool on their website, and they have a great list. They'll pop up a tree species list for you to plant going forward. So, yeah, good question.
Awesome. And Dominic had a follow-up question there. Dominic, I think you'd want to reach out to probably the East Metro Fisheries Office for Burnsville area. So try them first. So, well, Jeff said it's covered by the West Metro Fisheries. Okay. Don't know where exactly that border falls down there. So, anybody else has any other questions? We got another minute. Matthew had one more question. Can we expect to see the whitefish chain, Big Trout Lake, to hold lake trout for the foreseeable future? Either of you familiar with Big Trout Lake?
I can maybe speak a little bit to it first, and Heather can chime in too. Certainly the habitat is there. I think the area fisheries office is exploring alternative options for different strains of lake trout to be stocked into that system that might do a little bit better moving forward into the future. So hopefully with the actions that we're taking on the landscape and in the watershed to protect the habitat, that habitat will be maintained in the future, and then we can tweak our management strategies for that species in the lake. That would be ultimately moving things that direction as well.
Yeah, great question. We have been doing some conservation easements in the big trout watershed. And so there is work going on for protecting the forested landscape. And also the Soil and Water Conservation District, Crow Wing County, has actually been looking at like point source pollution. So I think it was about 8 or 10 years ago, there was a direct stormwater link from County Road 6 that went right into Big Trout Lake. And they actually put in a system that holds the water and gets filtered through before it actually goes to the lake. And then every year someone has to come out and pump out the sediment. And so there are initiatives going on, and that is a key water that we're looking at to keep the cold water habitat.
Great. One more question here we'll try to get to before we run out of time. Jeff had a great question in here about conservation easements. He says, when land is put into a conservation easement, what exactly happens? Does the DNR state own it? Do they have the option to sell it off in the future? Can it be preserved for no hunting? How does one leave it so it can never be built on? You want to touch on that a little bit, Heather?
Yeah. So a conservation easement really buys the development rights. So you take a chunk of land, if it's 40 acres, whoever purchases the conservation easement, so if they purchase it from Minnesota Land Trust or Trust for Public Land, they pay the landowner the development rights. So the land is appraised at full out development prices. And then it's also appraised with no development. And the difference between those two prices is what the landowner gets paid. So you can see, depending on where you live, that buyout of the development rates can vary around the state. It does still allow for whatever you want in the easement. It could allow for hunting, it could allow for forest management, timber harvest, but it really buys out the development rights, so you can't develop anything. And the language of the easement goes with the deed, and the title. So when you sell it to the next person, it stays with the title of the land and the deed. And so the next person can no longer develop it. So there is legal documents behind it. But yeah, you can basically set up a conservation easement however you want it. And you still own the property. That's the key. DNR doesn't own the property. Trust for Public Land doesn't own the property. You own the property. It just has restrictions as to how you can develop in the future.
Great. That was kind of a good rundown on what exactly an easement can entail. So I haven't had a whole lot of experience with that, but I know there's a lot of ins and outs that can happen in those. So I don't see any other. Jeff was also wondering, can the easement be removed in the future? So we hope not, but.
That's a good question. I think it depends on the initial easement language. I only know of one that's ever been removed, and that was with a landowner in Cass County, and it was a very old easement where the language actually precluded the current landowner to get out of it in the future. So it was like 50 or 60-year-old. It was a very old easement, and again, it was with Cass County. But today, a lot of them are in perpetuity. So they go with the title, they go with the deed of the land, and pretty much it's no development. Maybe if you hired a boatload of lawyers, you could get out of it, but it's really meant to protect the land from development in the future.
Sounds good. Well, thank you, both of you, for joining us today and talking about all this great stuff. Obviously, Minnesota is a land of 10,000 lakes, and we do a fair amount of fishing here, so we like to protect that and take pride in that. So it affects our well-being and our climate and the income of the state, which is great. So thank you. If anybody does have any questions, please reach out to me or Derek or Heather, and we will help you with anything we can. So I think with that, we'll sign off for the day. Hopefully everybody has a fun and safe weekend out there. It looks like it'll be a beautiful spring weekend. And maybe you can join us next week. Melissa's going to join us and talk about Southeast brook trout conservation in Southeast Minnesota. Another great species to chase in a little bit different part of the state. So thanks, everyone. Have a good weekend.
Thanks.